When someone with ADHD sits motionless in front of an important task they genuinely want to complete, what's happening isn't a failure of motivation or discipline. It's a breakdown in task initiation, the neurological process that converts intention into action. Dr. Russell Barkley's 2006 longitudinal study, published in the Journal of Clinical Child Psychology, documented how ADHD brains generate the signal to begin tasks through fundamentally different mechanisms than neurotypical brains, creating a gap between caring about something and being able to start it. Most approaches to ADHD task difficulties focus on motivation, finding your why, breaking tasks into smaller pieces, or pushing through resistance. This advice misses the core issue because people with ADHD already have motivation. They want to complete the task and understand its importance. The neurological bottleneck occurs at the initiation stage, not the caring stage. This misunderstanding persists because task initiation appears voluntary from the outside. When someone remains still in front of their work, it looks like a choice not to begin. The internal experience involves wanting to start while being unable to generate the neurological signal that triggers action. It's similar to having intact motor neurons but inconsistent nerve conduction. The intention reaches the brain's planning areas, but the activation signal to begin doesn't fire reliably. Willpower-based explanations appeal to people because they preserve the sense of control. If starting requires more discipline, then developing discipline should solve the problem. But ADHD brains often spend years or decades applying these strategies with inconsistent results, creating a cycle of self-blame when neurological accommodations would be more effective. The intermittent nature of ADHD task initiation compounds this confusion. When tasks are novel, urgent, or personally fascinating, many people with ADHD can begin immediately and work with intense focus. This variability makes the difficulties feel like personal failures rather than predictable patterns of brain function. Understanding why some tasks trigger initiation while others don't requires examining how ADHD affects the brain's reward and executive systems. Task initiation in neurotypical brains involves the prefrontal cortex evaluating a task's importance and generating activation signals that engage motor planning and execution areas. The brain's reward pathways help determine whether the task is worth pursuing now versus later. This system can typically generate initiation signals based on abstract importance or future consequences. In ADHD brains, this process works differently at multiple levels. Barkley's extensive research on executive function deficits, including his 2012 work published in Neuropsychology Review, shows that ADHD involves reduced and inconsistent activation of prefrontal regions responsible for executive function. Neuroimaging studies reveal that these areas don't show uniformly decreased activity. They show unpredictable activation patterns. Dr. Nora Volkow's 2009 study in the Journal of the American Medical Association documented differences in how ADHD brains process reward signals and evaluate task priority. The dopaminergic pathways that signal "this is worth doing now" show altered responses to routine, non-urgent tasks compared to neurotypical brains. This creates brain function that responds more reliably to immediate interest, novelty, urgency, or personal relevance rather than abstract importance alone. The neurological difference becomes clearer when examining the preparatory brain activity that occurs before task initiation. Cunnington and colleagues' 2005 research in NeuroImage shows that neurotypical brains typically display a gradual buildup of electrical activity in motor planning areas before people report feeling ready to begin. In ADHD brains, this preparatory activity is more variable and less predictable, regardless of conscious effort to initiate the activity. This explains why external structure often works effectively for ADHD task initiation. Body doubling, then working alongside another person, provides external activation that can substitute for inconsistent internal signals. Deadlines create artificial urgency that engages the brain's response systems. Environmental cues and timers can trigger initiation when internal mechanisms don't fire reliably. These strategies work because they provide alternative pathways to the same neurological endpoint. Task initiation difficulties in ADHD show significant individual variation that complicates both research and treatment. The same person might struggle to begin administrative tasks but start creative projects effortlessly, or find work tasks manageable while household chores feel impossible. This inconsistency reflects the complex interaction between task characteristics and individual brain patterns. Early ADHD research relied heavily on laboratory tasks that don't capture real world initiation challenges. Responding to computer prompts in a controlled setting differs substantially from independently deciding to start complex, self directed activities. Troll and Ebner-Premer's 2013 Ecological Momentary Assessment research, published in Annual Review of Clinical Psychology, reveals much more varied patterns of task initiation across different contexts and times of day. The replication crisis has affected this research area as well. Dr. Katyarubia's meta-analyses have found that while brain differences in ADHD are statistically significant, they're often smaller than initially reported and interact heavily with factors like genetics, sleep quality, stress levels, and hormonal fluctuations. Women with ADHD, who were largely excluded from early studies, show different patterns of task initiation difficulties. Research suggests that hormonal changes during menstrual cycles can dramatically affect executive function, with some women reporting that identical tasks feel impossible during certain weeks and manageable during others. This biological variability was invisible in research focused primarily on school-age boys. Autistic individuals with ADHD face additional complexity in task initiation. The autistic preference for predictability can conflict with the ADHD need for novelty and stimulation. Dr. Wen Lawson's research on monotropism suggests that autistic brains focus intensely on fewer interests simultaneously, which can either facilitate or hinder task initiation depending on whether required tasks align with current focused interests. Trauma history can also alter task initiation patterns in ways that overlap with ADHD symptoms. Dr. Bessel van der Kolk's work shows that chronic stress affects prefrontal cortex function, potentially creating additional barriers to starting tasks, particularly those that trigger memories of past failures or feel emotionally threatening. Medication responses show similar complexity. Stimulant medications can significantly improve task initiation for many people, but not uniformly across all tasks or times of day. Some individuals find medication helps with work-related activities but doesn't affect household tasks. Others report that effective morning doses become less helpful by afternoon. The reasons for these variations remain an active area of research. Recognizing task initiation as a neurological process rather than a willpower issue changes how you can approach daily challenges. Instead of asking why you can't just start, you can investigate what conditions your brain needs to generate initiation signals for specific types of tasks. This reframe shifts focus from self-criticism to environmental design. If your brain responds to novelty, you might vary your work location, use different tools, or approach familiar tasks from new angles. If urgency helps trigger initiation, you might create artificial deadlines or work in shorter time blocks. If external activation works, you might schedule body doubling sessions or work in environments where other people's activity provides stimulation. Research suggests that accommodating your brain's natural patterns is more effective than fighting them. This doesn't mean avoiding important but unstimulating tasks. It means finding ways to make them engaging, urgent, or personally meaningful. Sometimes this involves pairing tedious activities with interesting audio content. Sometimes it means identifying how boring tasks connect to your deeper values or long-term goals. For relationships, understanding task initiation differences can reduce conflict and increase support. When someone with ADHD appears motionless in front of a task they claim to value, they're experiencing a neurological bottleneck, not defiance or laziness. This knowledge can help partners provide environmental support rather than criticism, perhaps by working alongside them or helping restructure overwhelming tasks. In work contexts, this understanding can inform how you structure your schedule and communicate with colleagues. Instead of committing to start tasks at specific times, you might build in flexibility and explain that your productivity patterns are different but equally valid. You might advocate for deadlines that account for your initiation patterns or request that important tasks be presented in ways that engage your brain's response systems. Task initiation is fundamentally a neurological rather than moral issue. This doesn't eliminate your ability to influence it, but it does mean that effective solutions must work with your brain's actual operating patterns rather than against them. The goal isn't to function like a neurotypical brain, it's to become skilled at creating conditions where your brain can initiate tasks reliably. ADHD brains don't generate task initiation signals through the same mechanisms as neurotypical brains. Where most brains can begin tasks based on abstract importance or future consequences, ADHD brains often require interest, novelty, urgency, or external structure to activate initiation circuits reliably. The gap between intention and action reflects differences in prefrontal cortex function and reward processing, not character deficits. When you stop trying to force neurotypical initiation patterns and instead design environments that work with your brain's actual requirements, task initiation becomes less about overcoming resistance and more about creating the right conditions for natural engagement.